In this video, we're going to look at an exam question involving momentum in collisions. So two balls are colliding, and we need to look at the speeds, velocities of the balls after the collision. Now, the key result that we need in this is that momentum is conserved in collisions. What does that mean? That means that initial momentum equals final momentum. Okay. So let's have a look. In part A, we have two balls moving together at, well, we have two balls moving together. So we have to work out the initial momentum, the momentum of the two balls before the collision. Well, let's just say it's easy if we have one direction as positive. So let's just say that pointing to the right is the positive direction. Well, then momentum of A, so before. Well, the momentum of A is, momentum is mass times velocity. So mass is 3 and velocity is 4 to the right, so it's positive 4. So momentum of A is 12. And momentum of B is, well, now the mass is 2 and the velocity is now minus 4 because this is pointing to the left. So the momentum of B is minus 8. So that means the total momentum is 12 minus 8 is 4, and units of momentum are kilogram meters per second. Okay, so that's what's happened before. Remember, momentum is, I didn't write that down, but momentum equals mass times velocity. Okay, now let's look at after the collision. Well, after the collision, in this case, it says the particles coalesce to form a single particle. So now we have one big particle, which has a total mass of 3 plus 2 is 5 kilograms. And we need to work out what the final velocity of this is. Well, it's simple. Momentum is conserved. So momentum after is the same as momentum before, which was 4. So momentum equals 4. But that's also equal to mass times velocity. Well, my new mass is 5 and my new velocity is v. So I just get 4 equals 5v. Rearrange this, or solving this, we get v equals 0.8 meters per second. And that's a positive number, so these two balls are traveling together to the right-hand side. Okay, that's part A complete. Let's have a look at part B. So now the situation is slightly different because after the collision, A moves in the same direction as before with speed 0.4. So again, we'll look at after. We've got A is 3 kilograms and it's moving at 0.4. And it says, and we have to find the speed of B. Well, B has to be moving to the right, because if it was moving to the left, then it would have had to pass through A. So we know B is moving to the right. So B is going to be in this direction with a velocity of v, and the mass of B is 2 kilograms. Okay, so what's the momentum? Well, the total momentum is equal to, well, the momentum of A is 3 times 0.4, and the momentum of B is 2 times times v. And we know that's equal, that's the final momentum. Well, that must also be equal to the initial momentum, which was just 4. So we just solve this. 3 times 0.4 is 1.2 plus 2v equals 4. And that implies that 2v equals 2.8, which implies that v equals 1.4 meters per second. So that's what the final speed of v is. It's 1.4 meters per second, and it's pretty obviously moving to the right as well.